Today we're going to talk about water, and water is a unique substance to study. One of the main reasons is because on Earth we see it in all three states all the time. Of course, you can't really see gas, but we know it's there. Also, 75% of the Earth is covered by water, and that means we see it all the time here on Earth. In addition to that, 70 to 90% of all living things, oops, I forgot the L there, all living things is basically made of water by mass, which means we're made of water largely, and life processes take place in water. Water is frequently a reactant and a product, as you've observed here in your time in chemistry. The structure of water makes it very unique. One of the very first things we see that it's a polar covalent molecule. If you remember right, polar means that it's unequal sharing. We know that covalent means they're sharing, but it's unequal. So oxygen here, being very electronegative, pulls all the electrons towards it, which means we have a slight negative charge up here with the oxygen and a slight positive charge with the hydrogens. And because of that, we have this kind of bent structure here, 104.5 degrees between the hydrogens that make that a very unique molecule. And due to this, water molecules like to form H bonds between it. So this is one water molecule, here's one water molecule, and between those water molecules we have these weak hydrogen bonds. Now, the weak hydrogen bonds, they're weak individually but strong together. And these are really the main explanation on why there's so many types of very special properties about water. The H bond is the explanation typically. So what are those unique physical properties? Here's just a few. The first one is that water freezes, ice melts, same thing, going different ways at 0 degrees Celsius. That is a pretty high freezing point. Molar enthalpy of fusion, which is just the energy it takes to break the ice down into a liquid, is very high. And we wonder why, again. The answer is H bonds. H bonds sort of want to hold the water molecules together so that they don't melt. Also, water expands in volume as it freezes, which is unique. As it freezes, those H bonds kind of push the other molecules of water apart, and it becomes a very rigid, ordered structure. Think of a snowflake. If you've ever seen a snowflake up close, a snowflake is very ordered and has a really neat pattern. So the water molecules are pushed away into this very neat structure, which creates an expansion in volume. Lastly, water boils at 100 degrees, which means it has a high molar enthalpy of vaporization. The reason, again, is relatively high because the H bonds are holding the water liquid molecules together, and they don't want to escape to a gas form. And the H bonds, again, are the culprit in keeping that boiling point very high compared to other molecules. So there's a short little video kind of explaining some things about water, and hopefully this helps you out in understanding this awesome, unique substance we have here on Earth.